Great weekend. Today we are going to begin a new unit, but before we begin the new unit, we are going to look at Friday's unit exam. Okay. How many of you in this class have not taken the exam? Everybody in this class take it? Okay. So let's go over the unit exam and then we will get started. If you fail the unit exam, I will be scheduling a time for you to come take it again if you do not come on your own. So if you're not here before Thursday to take it, I may call you Wednesday during advisory or Thursday. Definitely. Come during advisory to retake it. And I'm going to go over the answers. You'll see the answers. And then you will be able to study the test, come in and retake it. Okay? I need a volunteer to hand these back. Okay, when I call your name, come up and get this sheet. If you have one of these little sheets stapled to it, that means you have to take it home and get it signed.
So it's better to let them call out right there, so you have to do it again.
Well, everybody, I'm going to call everybody. If yours has a little sheet stapled to it, that means you have to get it signed. Okay? No dolphin today?
No.
Bryn? Gracie? You just were in the restroom. I was in there with you. No, you can't go to the restroom. Catalina? We have time to identify all of you. Hanukkah?
Right there.
Jacob? Armando? Galia? Lane? Alexis? Carrie? Jace? Does everybody have their test back? Farah? Destiny? Sterling? Angela? Thank you. Just because Raphael's not here. Raphael.
He's around. He's here. He's on his way.
Freddie? Gerardo? Daniel? And Madeline. Everybody should now have a copy of the answers. We will be going over the test. I'm going to model for you how you should have taken this test. Those of you who didn't do so well need to really pay attention. We'll take about 15 minutes to do this, maybe a little less. So let me start by pulling this up where you will be able to see the test. Remember, when you are given a model like this, and it's guaranteed that you will see this again on probably the next unit test, because my unit tests are cumulative. Remember, if the protons and neutrons are not labeled for you, in order to find out which ones are the protons, what do you have to count?
How many electrons?
How many electrons? So there's 1, 2, 3 electrons. Those of you who are failed should really be taking notes on your test booklet and paying attention. So we know if there's 3 electrons, these B are the protons. So number 1 was B. Number 2, which letter represents the electron? Hopefully everybody knew that the electron is in the electron cloud. It was C. What is the electrical charge of the subatomic particles located at B? B is here, it is a proton, and it would be A, positive. The protons are positive. Number 4, identify the subatomic particle indicated by letter A. Well, the two in the nucleus are protons and neutrons, so we now know that the B is the neutron, because, A is the neutron because B was the proton. They all have your test here to get it to you. Okay, number 5, identify the area of the atom indicated D, that is the nucleus. Most everybody got that one right. Number 6, how many valence electrons? Too many people miss this. This is the outer shell. Right here. How many electrons are in it? 1. G. If you missed that, you just have not been paying attention for 2 weeks. Okay, next page. Mass. I think almost everybody got this one correct. Okay, you had to count what was in the nucleus. Here it was 7. Here it is 8. Here it is 7. Here it is 5. It asks which one has the least mass.
D.
So it was D, the one with 5. Niels Bohr. Bohr discovered the shells, whose work in the 1920s was accepted and used by the following future. Which of the following discovery is known for? And the model atom built up excessive shells. There it is. It was F. Just have to know that Bohr was shells. Number 9. An atom consists of 11 electrons, 12 neutrons, and 11 protons. What is the electrical charge of the electron cloud? Which particles are in the cloud?
Electrons.
And what charge are they?
Negative.
So it would have been C. Negative 11. Because there are 11 electrons and the electrons are negative. Number 10. What is the SI unit for atomic mass? Well, it was an AMU. The atomic mass unit. H. When determining an element's identity, here's the clue word right here, identity. And you should know when you see the word identity, it has to do with the protons, C. Protons, C. Okay, this was a long question. This one was actually on last year's STAR test. Okay? You have to read, it says which of the statements above correctly represents the mass of particles. So you have to read each one. An electron has the same mass as the proton? No. An electron has much more mass? No. An electron has about the same mass? No. An electron has much less mass? Yes. An electron has much less mass? Yes. A proton has more mass than an electron? Yes. A proton has less mass than an electron? No. A proton has about the same mass of a neutron? Yes. A neutron has much more mass than a proton? No. A neutron has much less mass than a proton? No. And the way you remember that is because the proton, the neutron, and the electron have mass. And it's 1, 1, 0. Using that information, you then have to decipher all of this. The answer was 4, 5, 6, and 8, which was J. 4, 5, 6, and 8, which was J. Questions? Okay, number 13. To get, when I say neutrons, what math function should you do? This was a subtraction problem. All you have to do was subtract. You take the mass, which was 40, and the protons, which were 18, and you subtract them. And it should have been 22. That's all there was to it. That's simple. Some of you didn't subtract correctly, which was unfortunate, especially since you're an 8th grader. What is the atomic number of the atom in figure 2? Well, the atomic number is the protons, so it was 14, J. You just have to memorize atomic number is protons. It was this part of our little mnemonic. 8. What element is represented in figure 2? Well, you have to take the 14 protons, go to your periodic table, and find out that it is silicon. D. Just have to go and find it on the periodic table, 14 protons. We grab a periodic table and show you how to do this. This is, for those of you who didn't know how to do this, and there are several of you in here didn't, remember you go to the top number, 14 right here, and that tells you what element it is. That simple. This couldn't be any easier. Number 16, how many valence electrons? You have to count the ones in the outer shell, and there are 1, 2, 3, 4. Or you could have looked at, oh, it's silicon, and gone up and seen the 4A group, and no, it was 4. So you could have done it either way. Number 17, what is the mass? Okay, mass, you have to add protons and neutrons. 14 plus 15 is B, 29. Density problem. Most people just skipped it or guessed, which was unfortunate. This was on last year's STAR test. They're not going to get any easier than this. And this one was a little difficult. Okay, it says, for an investigation, the student recorded data about 4 unknown substances. The student then calculates the density of the unknown substances and compares them with the table below. So you have to calculate the density here of each one of those. Density equals mass over volume. So 6.95 divided by 4. And then you could have just had plenty of room down here to do the math. Bring your decimal up. Carbon. Is that one going to be carbon when it starts with 1? So do I need to divide anymore? No, you didn't even have to divide it all the way through. Work smartly. Go to the next one. 4.54 divided by 2. 4 into 2 is 2. Are any of these other ones 2?
Yes.
It is. Now we know this one's either sulfur or carbon, so we're going to have to divide a little bit more. 2 goes into 5. 2. Can it be sulfur? No. So we know substance 2 is carbon. It was that easy. That's the only math you have to do. You know, when you have math problems on the tests, work smartly. Did I have to divide this one all the way out? No. You have to work smartly. Okay, next one, number 19. We know that X could be either a proton or way far enough away. If the building's on fire that much, we would continue walking up the street.
I'm ready.
Okay, number 19, which of the best describes a subatomic particle labeled at Y? Well, Y we know is an electron. You should be thinking it has 0 mass. It is negative. The particle Y has no charge. Well, that's wrong because it's negative. It has a negative charge and absolutely no mass. No, that's wrong. It does have a little bit, remember. The particle label Y has no positive charge. The label Y is negative and has less mass. Yes, that's it. It was D. That's the way you have to think about these things. Take them one at a time, read each one, and apply what you know. If you didn't know that the electron was negative and had 0 mass, well then that's the problem. You didn't do enough studying or you didn't pay enough attention in class. You know, there was 100 in this class. Somebody can make 100 on this test. That means that it was possible for everybody to do really well. Okay? Because I didn't explain it to them any more than I explained it to anybody else. And there were 3 or 4 or 5 A's in here. So when you have A's and then you have 30s, there's something wrong. Okay? J.G. Thomson, well, he did the electron. What did he discover? It was the electron, G. Number 21, the total number of protons and neutrons. When you add them together, that gives you the mass. So it was B. Okay, on this one, according to the periodic table, which of the following Bohr models represents sodium? Well, you just have to find sodium on the periodic table and find out how many protons it has. It has 11. So you just look for the model that has 11 protons. Oops, there it is, G. G. Okay. 23. How many protons would an atom of sulfur have? Well, you go to your periodic table, you find sulfur, and it's 16. It would have been D. Just have to look it up on the periodic table. What is the definition of atomic number? Well, atomic number, we learned 8. Atomic number is the number of protons. plus neutrons. It's not the number of neutrons. It's not the number of electrons. What are the valence electrons? They're the ones in the outer orbit. C. Outer orbit. Some people put B. It's just not studied. 26, what is a subatomic particle with a negative charge? That would be the F electron. Again, that's just a vocabulary word. That's a definition. 27, which of the following is the best description of an atom? An atom, remember, has a core surrounded by electrons. And C, it's a core of protons and neutrons surrounded by electrons. Valence electrons for lithium. You find lithium, it's right here. You go up and see what A number, and it is 1. So there's 1 valence electron. That easy. You didn't get that right, you just didn't pay attention for 2 weeks. Number 29, what is the mass number of a potassium atom that has 20 neutrons? Well, to get mass, what two things do you add together? Protons and neutrons. Well, it tells us we have 20 neutrons. How many protons does potassium have? You go to the periodic table and you see it's 19. So 19 plus 20 is 39. That simple. Okay, number 30, what is the total number of protons, neutrons, and electrons? Protons, neutrons, and electrons, and we want the total, so we're going to be adding those. Okay? It says here the mass is 133. What do you add together to get mass? The protons and the neutrons. So these three, those are 133. Now, from APE, we learned that the protons and the electrons are equal. So in order to find out how many electrons we have now to add to it, we have to find cesium. Here it is. Here is the number of protons, 55, and that's also the number of electrons, 188. Anybody in this? Well, I know one person got it right. Some people get that right. I think some people did. Do you understand why now? Okay. Number 31, the table below lists characteristics of an atom, of an element. Here's the most important thing right here, because the protons identify it. An atom of which element? Well, you have to look up 37 protons. 37 protons is right here. It's Rb. That makes it C. Number 32, a chemist is identifying an element present in a sample of seawater. What characteristic of an element's atoms determines the element's identity? That was exactly the same as this question. It's the number of protons, F. Last but not least, in the early 1900s, many scientists thought that an atom consisted of a positive substance with a negative charge scattered throughout the substance. Then Ernest Rutherford, who discovered the nucleus, or the proton, containing the proton, did an experiment. His discovery led to the understanding that an atom consists mostly of empty space with B, electrons orbiting a dense nucleus made of protons and neutrons. Questions about this? Okay, get out your green folder, please. This goes, hole punched, it goes at the back of your green folder. Open up the brads and put it behind your workbook in your green folder. Right back there. Okay. And in the meantime, while you're going over that, I'm going to put up the table of contents, and you need to add this to your table of contents. We're going to be working really quickly since we're shorter on time than I had hoped. So add that to your table of contents, and I'm going to be passing out some papers for you. What's that? Okay, those of you who have to retest, now you have your test to study with. So study it, come in and retake it. You gotta get that signed.
Question.
Yeah. No, well, that you can go away. Did you go through and mark the correct answers? Yes. Yeah, you can go away. Okay, Unit 3 is the periodic table. Here's your unit organizer. We'll go over this real quick in a moment, and also I have your vocabulary for you. Go ahead and get these glued down and onto page 18 and 19. The vocabulary you're going to have to trim at the bottom. And the warm-up, we didn't have time to go over. Just put it in your warm-up folder for now, and we'll go over. That'll be your warm-up tomorrow. Okay. Ready? You want This goes on page 20. You can glue them all down. Page 18. Everybody grab one of those? Okay, unit organizer. Fold in half, glue down to page 18. I'm going to go over it real quick while you're gluing it down. If you didn't get the table of contents, it'll come back up later. Okay. Unit 3, periodic table. Your vocabulary, atomic number, atomic mass, group, period, metal, non-metal, metalloid, reactivity, conductivity, malleability, luster, ductile, and density. Most of this unit, that goes on 19. We're doing this one first. Grab that one. Yeah, grab the unit organizer. It looks like this and glue it down first. Page 18. And then open it up and look at it. We'll get to the vocabulary next. Page 18. Okay, periodic table, unit organizer. Should be glued down to page 18. Okay, periodic table is about understanding the arrangement of the elements on the periodic table by differentiating between atomic number and mass number. This we've already been doing. You should know that the atomic number is the number of protons, and the mass number is the number of protons plus neutrons. Okay. We will also be differentiating between groups and periods. Groups are the columns, and they tell us the number of valence electrons. And while you're gluing, just be listening. And periods are the rows, and they tell us the shells. We'll also get to know the important groups, and you will have to memorize these groups. Alkaline metals, alkaline earth metals, transition metals, boron group, carbon group, nitrogen group, oxygen group, halogens, and noble gases. Okay? Finally, we will talk about locating and analyzing metals, nonmetals, and metalloids. You need to know luster, conductivity, malleability, ductility, and density. So we will be doing more density during this unit. Okay? Okay? Again, I expect you to read the unit self-test questions. At some point, I may make you go back and answer some of those questions on a sheet, so make sure you're looking over those. Any questions about what we're studying in this unit? Periodic table, yes. Okay, grab your vocabulary, cut off the bottom little piece, glue it down to page 19. Which, yeah, the page numbers are not right for this class this year. But let's take a look at these. I'm going to let everybody because we're going to do some clue words again. You'll need a highlighter or your pen to underline some important words. So get them glued down, page 19, and then grab a highlighter. Was this an extra one? Everybody get one of those? Okay. Grab a highlighter, your pencil. If there's not a highlighter in the box, let me know and I can bring some more around.
We're missing some highlighters.
There you go.
We don't have five over here.
Okay, number one, atomic number. Highlight the word protons. The atomic number is the number of protons. What's the atomic number? Number of protons. Atomic mass. Highlight protons plus neutrons. Atomic mass, what do you add together? Protons plus neutrons. Very good. Group. Highlight vertical column. Vertical column. What does vertical mean? Up and down. Also highlight the word reactivity. Vertical column and reactivity. That's going to become very important this unit. We talked about that a little bit in atoms, but now you're going to have to learn it. It'll be on your test about reactivity. Okay, period. Highlight horizontal row. What's horizontal mean? Period. This way. Okay, it's the horizon. Metal. This one, you're going to have to know they have luster, highlight luster, malleable, and ductile. Luster, malleable, and ductile. You're going to have to memorize those characteristics. They also highlight conduct heat and electricity. Luster, malleable, ductile, conduct heat and electricity. That's one of the longer ones you're going to have to memorize. Non-metal, brittle, highlight brittle. Do not conduct heat nor electricity. Do not conduct heat or electricity. So what do you think? Metal or non-metal? Non-metal. Plastic. Metalloid. Characteristics of both. Characteristics of both. Yeah, you learned this in 6th grade. This will be a review. Most of these units of review, we're only spending a couple of, 6 days on it. Most of this is review. Reactivity. Undergo a chemical reaction. And then underline valence electrons. Undergo chemical reaction, valence electrons. But you're going to have to remember that reactivity is a result of valence electrons. Okay? Conductivity, transfer heat or electricity. Transfer heat or electricity. So if something is conductive, it transfers heat or electricity. Malleable, formed by hammering. Formed by hammering. So if you have a hammer and you beat on something and you're able to bend it, it's a metal. If it's a non-metal, it would break. Brittle. Okay, that's all from 6th grade again. Luster, shining. Shining. Ductile, wires. Ductile wires. Okay. Now there's a little sheet called Periodic Table Basics. Please glue that down on page 20 if you haven't done so. And we're going to do a little activity. Each table is going to get about 3 of these little cards, and y'all as a group need to complete them. What you're going to be doing on these little cards, you'll need your periodic table in your journal. So on these little cards, here's one of these cards up here. What you're going to do is you're going to fill in the information from the periodic table. This is many protons does it have? 1. What's its name and what's its mass? And then you're going to count the protons, neutrons, and electrons, and then you're going to draw your model. Okay, so everybody's going to get 3 of them.
You want to see all this?
Yes. And the Lewis dot diagram as well. Okay, I'll get those done. Can y'all do 4 for me? I'll give you 3 for now. Not yet. We're going to take notes on there. Y'all do 4 for me? Get them done quickly. Almost bust. Okay. Okay. You only have 2 to do this. Okay, I'm done. You have 3 minutes to get that done. We got to move on. 3 minutes. If you're not sure what to do, raise your hand and ask. No, you're doing everything else. You're just copying that information. Protons to so how many electrons? Okay, the neutron. You got these 2 numbers? What do you do these 2 numbers to get the neutrons? What do you do those 2 numbers to get the neutrons? What's the math you do to get neutrons? You say this over and over. You subtract. Okay, you subtract the 2 here. Protons and electrons should be what? The same. Okay, did y'all get them done? Y'all get y'all done? Okay, very good. I'm going to call up somebody randomly, somebody's table, and I want you to bring your cards up. How many of you still need some time doing it? Okay, 1 more minute. We got to move on because the bell's going to ring. We only have about 15 minutes. We've got other things to do. Now get the neutrons. Okay, I'm going to call somebody from a table. You grab one of yours, you tell me what element it is. I want everybody to close your journal. Close up your periodic table, please. No periodic table is visible for you to see. Okay, I'm going to hand you a piece of tape, and you're going to come up and see if you can figure out where to place it from memory, given the information on your little model. Well, how many other times do you go? Okay. Well, it doesn't have one. Okay, Gracie, bring your card up. Put that on the back and tape it right on the screen where you think it belongs. Okay, why did you place it there? Well, 14 tells you what? Okay, the common number, but that's not what you should use to place it. You shouldn't be using the protons. Okay, you have it in the right place, but you're not explaining to me why you did it there. Okay, have a seat. You're in the right place, and we'll see if the next person is. Farrah, bring yours up, please. Put this piece of paper back and put it where you think it belongs. Okay, why did you put it there? Okay, that's not one of the reasons why we were going to place it. Remember, it's what we learned already, thinking about the rows and the columns. Okay? Okay. Ms. Miller, bring yours up. Everybody needs to listen so you learn. Take yours where you think it belongs. Okay, why don't we put it there? Very good. It's in 2A. That means it has how many valence electrons? 2. Right. It has 2 valence electrons. So it is going to be in 2A. Okay? How many shells does it have? 2. So it's going to be in? Row 2. Row 2. Everybody understand how to do it now? James, bring yours up. But you're using the... Yeah. Why did you place it there? Very good. It's in 2A and has 3. How did you know it was in 2A? What does it have? 2 grams. Awesome. Good. Next person. Somebody. Chris, come on up. Place yours where you think it belongs. Why there, Chris? Everybody pay attention? How many valence electrons does it have? 3. No, valence electron. Oh, 1. Yes. It's in row 1. It's in row 1. How many shells does it have? 2. So it's in column 2. Okay, let me just tell you now that these columns have a name. And they're called groups. Everybody say it? There's group, 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 groups. The rows where you see the shells are called periods. Everybody say it? Okay, Daniel, bring yours up. Raphael, bring yours up. You have one? Or Ms. Niner, bring yours up. Put it where you think it belongs. Put it where you think it belongs. Yes, Jacob, come on up. Right there, Daniel. Everybody listen. How many shells does it have? And how many valence electrons? Very, very good. That's exactly right. Everybody listen. Daniel put this one here because it has 7 valence electrons, so it has to be in this column, because this is 1, 2, 3, 4, 5, 6, 7, and it has 3 shells, so it has to be in 1, 2, 3. Ms. Niner, you did yours right. Good job. Jacob, your turn. Why there? It is group 3. Why group 3? By what? By what? It doesn't, okay, but that's not the reason. Why is it in group 1A, 2A, 3A? Why is it in 3A? That's exactly right. Gerardo? Why there? Valence electrons. And how many shells? 2. Armando? Ready? Okay, how many valence electrons does it have? 3, that's not the right one then. Because here's 1, 2, 3. There you go. Here's just 5, so 3, 4, that's right. Okay, we're going to leave it right there. I'm going to add some notes to that journal sheet, so open it up, please. We have 3 minutes to finish this up. This is the way it should look when you were finished. Please add these into the sheet on page 20. Wish we would have had more time. Remember, the 1A's tell you what? Yeah, and the A groups tell you the valence electrons. What do the period numbers tell you? The shells. Okay, look at the elements in the third row. What do you notice about their structure? What do they have in common? They all have? They all have 3 shells. Okay, they all have 3 shells. What about the elements in the second row? They all have 2 shells. Look at the elements in the first column. Column. What do you notice about their structure? What do they have in common? Nope, column. They have 1 valence electron. What about the elements in the last one, 8A?
They all have 8 valence electrons.
Okay, this is where you have to think of something different. Because remember, helium only has how many? Okay, so for this last column over here, you can't think about having 8 valence electrons. What you think is that they're full. Okay, it's full. We're nowhere near finished. Keep your notes out. Okay, now on the periodic table, these different columns have names. The first one is called the alkali metals. Alkali metals. The second one are called the alkaline earth metals. Then we have the boron family, the carbon family, the nitrogen family, the oxygen family, the halogens, and the noble gases. Please add those to your information there. What's that?
Not everything, but the stuff in
Yes. So everything in the first column, all the way down, are called the alkaline metals. Everything in the second, 2A, are the alkaline earth metals. Everything in this column is called the boron group, or boron family. Family and group is the same thing. You can use those words interchangeably. You and your family are what to one another? You're related, usually, okay? And the elements in, for example, the boron family are all related because they have 3 valence electrons. That's what makes them related. Okay? That's what makes them related. This is your homework. You'll need those names in order to do your homework, so hopefully you've written them down.
You did this? And I did
Just leave that right there. Here you go with my homework. You must do this.
No!